Hello, today we're going to start with section 4.5. In this section, we are going to learn about exponential and logarithmic equations. So let's take one word at a time. What does equation means? Equation means we have an expression where it's left hand side and right hand side and we have to solve it. Solving it means finding the variable's value. Now we are talking about exponential and logarithmic equation, meaning an equation which has either exponential function or logarithmic function is them. So first kind of exponential equation we can do are which can be solved using equivalence property. What is equivalence property? If we have b, x and y are any real numbers, b is positive and b is not equal to 1. If b raised to power x is equal to b raised to power y, that means in an equation both sides are exponential of the same base, then their exponents would be equal to each other. That means x would be equal to y. Okay. Now, what is the logic behind this kind of equation? Means that both sides of the equations can be made exponential function with the same base. Now let's look at part A of equation 1, example 1. The left hand side is 3 raised to power 2x minus 6. The right hand side is 81. Can we write 81 as power of 3 somehow? I think 3 raised to power 4 is 81. Now equivalence property come into play. Both sides of the equation are the exponential functions. Both sides of the function have the same base, right? That means their exponents should be equal to each other. So that would give me 2x minus 6 is equal to 4. Now this becomes a simple linear equation which can be solved by isolating x. We can add 6 on both sides. That would become 2x is equal to 10. We can divide by 2 on both sides. That will give us x is equal to 5. So that is the solution. Solution meaning the value of the variable which satisfies the given equation. So x is equal to 5 is solution to the given exponential equation. Let's try part B. Left hand side is 25 raised to the power 4 minus t. Right hand side is 1 by 5 raised to power 3t plus 1. We want to think how can we make the base on both sides of the same. I think the left hand side can be written as 5 square, 25 raised to the power 4 minus t. 1 by 5 can be written as 5 raised to power negative 1 raised to the power 3t plus 1. Power of power multiplies. So that will become 2 times 4 minus t is equal to 5 raised to power negative 3t minus 1. Now we can say the base on both sides is same. That means the exponents should be equal to each other. So we can say 2 times 4 minus t is equal to negative 3t plus 9 minus 1. We can distribute it. 8 minus 2t is equal to negative 3t minus 1. We can solve it by isolating t on one side. So we can subtract 3, add 3t on both sides. It would give us 3t plus 2t, and we can subtract 8 on both sides. 2t was negative here. 3t minus 2t is t is equal to negative 9. So we found the value of the variable. That is your answer. Let's try one more example. 1 by 4 is equal to 8 raised to power x. How can we make both of the sides the same base exponent? So 1 by 4 can be written as 1 by 2 square. 8 can be written as 2 cube raised to the power x. 1 by 2 square can be written as to the power negative 2 is equal to the power. Power of power multiplies. Bases are same on both sides. So the exponents can be equal using the equivalence property. So we have negative 2 is equal to 3x. We can divide both sides by 3. That will get us x is equal to negative 2 by 3. Answer to our problem. Part D. 8 raised to power x plus 3 is equal to 4 raised to power 5 minus 2x. Two equations, they both look similar, but they don't have the same base. But I think 8 can be written as 2's power 3 to the power x plus 3. 4 can be written as 2's power 2 to the power 5 minus 2x. Power of powers multiply, so that is 3x plus 9. 2 raised to power 10 minus 4x. The bases are same, so equivalence property applies. This expression would be equal to this expression. So 3x plus 9 is equal to 10 minus 4x. We can isolate x on both sides by adding 4x. So 4x plus 3x and subtracting 9 on both sides. So what do we have? 7x is equal to 1. X would be equal to 1 by 7. That is your answer to the equation. Now, most of the exponential equations cannot be written as the matching basis. So, previous example we did, all of those equations were able to write with the same base. But no, it's not always possible, right? So, now we have some equations which cannot be written as the same base. What do you have to do? Isolate the exponential expression, then take the logarithmic on both sides. Then apply all the properties of logarithmic. It gets easier. Let's see. We have example number 2, part A, 7 raised to power x is equal to 60. Now I cannot think of how I can write 60 as 7's power. So I cannot make the both sides matching bases. So what we can do? Isolate exponential expression. Exponential expression in this case is 7 raised to power x. It's already isolated. Now take log on both sides. So we can take log on both sides. That would make log of 7 raised to power x is equal to log of 60. Now what does log's property do? The power property brings this x down here. So we can say x times log of 7 is equal to log of 60. Now log of 7 is just a number. We can divide both sides by log of 7. So we have x is equal to log of 60 divided by log of 7. We can find that using calculator. So I have used common log in this case, common log of 60 divided by log of 7. Now, it depends what you take here, but you can take natural log too. It will not change your answer. You can check that statement too. But this is your answer to the given equation. 2.10. Let's try one more example. Part B, 5 raised to power x is equal to 83. Now, I don't think I can write 83 as 5's power. So, I'm going to take log on both sides. Now, I'm going to show you natural log on. You can take any one, common log or natural log, but take it on both sides. So, natural log of 5 raised to power x is equal to natural log of 83. Using power property, this power x comes out. So we can say x times natural log of 5 is equal to natural log of 83. So x would be equal to natural log of 83 divided by natural log of 5. We can use the calculator for that. 2.74. So answer to this problem would be 2.74. Let's try one more. Example 3, part A. 10 raised to power 5 plus 2x. Now that is the exponential portion. Plus 820 is equal to 49,600. Now the first step is to isolate the exponential. Exponential is this portion, so I'm going to subtract 820 on both sides to isolate that. So I am left with 10 raised to power 5 plus 2x is equal to 9,600 minus 820 is this. Now we isolated the exponential. We have to take log on both sides. So until now I said you can take any log, but in this case the base here is 10, right? So it's preferable to take common log on both sides. You will see why. On both sides. So we have log, which is common log. 10 raised to power 5 plus 2x is equal to log of 48,780. Now here pay attention, I said log and 10 power. They are common log and 10 power. They are inverse of each other, so they are going to cancel each other. So what are we left with? We are left with 5 plus 2x is equal to log of 48,780. We got rid of log. There is no exponential, there is no log. Now we have simple linear equation. We can solve by subtracting 5 on both sides. So we have 2x is equal to log of 48,780 minus 5 divided by, now you can divide both sides by 2. So we have x is equal to log of this minus 5 divided by 2. We can use the calculator to do that. Log of this minus 5 divided by 2. So we have x is equal to negative 0.155. You can round it off by writing 156. That is your answer. Here we have part B. Again, isolate exponential. Exponential is this portion here. To isolate, I'm going to divide by 18,000 on both sides. So I have e raised to power negative 0.4t is equal to 1 by 9, because this will cancel it at 9. Now, I have isolated the exponential. I can take log on both sides, but because the base is e, I am going to take natural log on both sides. So what do we have? Natural log of e raised to power negative 0.4t is equal to natural log of 1 by 9. Now remember, natural log and e cancel each other. We are left with negative 0.4t is equal to natural log of 1 by 9. T would be natural log of 1 by 9 divided by negative 0.4. Let's look at part C. 3 raised to power negative 0.02x is equal to 0.07. Now exponents is already isolated and the base is 3. So we can take any log, common log or natural log. Let's take common log on both sides. So log of 3 raised to power is equal to log of 0.07. Using power property, dividing by the constant on both sides, x would be equal to natural log of 0.07 divided by